trained from stretching if there's movement, but just a different way of getting the job done. I thought I'd toss this one in because this is a really unusual job. It's a TPO membrane over insulation. I rather like it because it shows you the setup, and in this particular setup we have our insulation layer and the fixing plates have gone through on top of the membrane. Your next sheet overlaps and covers them. Where we have high foot traffic, we'd put another layer of 12mm facer board that's got fiberglass and so on to take more load. So whenever you do a membrane like this with ballast on it, we'd put the insulation, the cover board, and then go through. This is very big in Europe a lot of metal roofing. Put it through. Here we have a vapour barrier because that insulation is the PIR type, a bit susceptible to holding water. Keep it dry and it works well. Loose laid membrane with ballast. You can't really tell, but on this one, the face of the board should be there. Just bear in mind, these are only examples, they're not the final solution. Different one, inverted roof assembly. So we've got the structural roof, membrane, insulation, geotextile, and landscaping. Fully adhered, other option we've got is gluing the membranes in place. Most of these adhesives are solvent-based systems, but you know, it's all dissipated, there's no lingering smell once it's set. Beauty about all of these is we do wind uplift calculations. So we can measure the wind uplift force, and particularly with mechanical fixings, decide whether or not the fixings are enough to prevent the membrane being sucked off the roof. With the adhesives, the biggest one we've done is with butyl rubber, 3,000 metres on the new gas refinery up at Curtis Island, Gladstone. All glued down, and we did the pull-off test and so on, and it met the requirements for that cyclone region. And it hasn't leaked. The thing I liked about it is when I first met the developers for that, their requirement was for a gas-proof membrane because they described their admin building as the bomb blast bunker. So the building is actually slightly pressurised, so the hydrocarbon gases don't leak into the building and explode. I thought, well, I'll take the money, it's all good. But yes, it worked. So insulation details. This is the original method of mechanical fixing, and what we've done here is shown that our weld, this is the welded section, works quite well. All much the same, fixing plates, we're saying, so 50mm from the edge, things like that. But the automatic welding seam is going to give you a wider weld than hand welding. So you do the bulk of your welds with a robotic welder and works pretty well. Detailing, round like that. With all of these single ply membranes, we always have some base time, some more than others, but particularly at perimeters, and there's two ways of doing it. You can put the fixing plate on the vertical, you can put it on the horizontal. It's just whatever works on the job. Either way, you try to make sure that your overlap is always going to be water shedding and not finishing here where a little gap can hold water. We also get, with a lot of these products, preformed mouldings for corners, internal, external, and it's fairly common across the range with a lot of these products that they're available. The new system of welding, though, is a little bit different. Same plates, but with coated with the polymer material. We only have experience with the TPO ones, but you can get them, fasten them down through your insulation or whatever it is that you've got to. Roll your sheet membrane out, weld the overlaps, and then come back with an induction welder, put it on the plate, heat it up, and you have a bond achieved and you still have a flat membrane. We talked about reinforcement previously. Once you've installed your plates or whatever and you're ready to go through the membrane, we always say with these sheet membranes you should do a test. Make sure that the temperature of your welder is up to speed. That's just a demonstration that when you do a destructive test piece before you actually weld the job, you should be able to rip it apart like that. You know that your material has welded. If it pulls off and you still have material in the reinforcement, you haven't got enough heat in there. An example of some of the welding machines, motorised ones. On the motorised ones, you can set the temperature, roughly around 550 degrees C. You can set the speed from 1 metre per second up to about 10, something like that. You can set the airflow rate on your welder, because if you have too much velocity in the hot air, it will soften the material ahead of the welder and your automatic welder won't roll along the seam perfectly. So just little things that work. To just give you an idea how similar these products are, you look at the welding speed and the temperature for PVC compared to TPO. TPO, a little bit broader ability, so very similar. We find that a lot of the guys that have been brought up on PVC love to make it smoke. Generally, if it's smoking, it's too hot, and even though the TPO is showing that it can take a higher temperature, we don't need to go there. If it's smoking, you're damaging it. We also have with all of these products some prefabricated scuppers and other accessories. We still recommend with some of them that you need to have some mechanical fixings. With a lot of the rubber, EPDM and butyl rubber, you also detail sharp edges and so on before the membrane goes down. Don't need to do that with the PVC or the TPO. It just helps protect the membrane. I mentioned previously we glued and stuck down butyl on rubber. In this one, where we do overlaps, we put a seam primer. There's 2 self-adhesive tapes that we put down and then roll the joint and you have a watertight joint. We've done this generally for roofing and occasional ponded areas. Where we have total immersion, it's always better to have a vulcanised edge.